Okay, so imagine a circle that consists of all of the human knowledge, anything that you can learn, from geography to history to philosophy to English to Chinese literature to Chinese old literature to physics to accounting to management to business. Okay, you get the point. Many things here. So by the time you finish like kindergarten, you learn a little bit lah. You learn a little bit about everything. Like, you know, oh, got this thing, oh, got that thing, but you don't really know how it works. Okay, we know all got all these things. And then by the time you finish high school, you learn a little bit more about everything. That's why in high school, you take so many subjects. That's why we want you to take history, while we want you to take languages, but we also want you to do sciences, but we also want you to do maths, but some of you go and take account. Same thing. Because we want you to have enough chance to have that can't see all the different possibilities that are currently available to you and figure out which one gives you like, yeah, this is something that I want to do every day. So sometimes people will ask me why I teach. Why do I teach? Because I'm overqualified. I like teaching because it's me. It's something that I've done a long time and I like doing it. It's as simple as that. How do I know I like doing it? Because I did a bunch of other things. And then I figured that this is still the best fit. It's the same idea. When you do a degree, you gain a little bit of specialty. Maybe it's accounting. Maybe it's computer science. Maybe it's programming. Maybe like my brother, you go and do game design. So he design mobile games and get you to buy things. Hey, money, got psychology there one. Maybe it's counseling. I don't know lah. Whatever it is, you get a little 专长. This is good enough. You can go and work already. So the whole point of you right now, because you're in this phase, is to know what is out there, know how the world looks like by reading. Don't just read the sensational articles. Don't listen to what Miss Lee say. Miss Lee say the world 好像要 end 这样子, the country like going to go very bad. Do your own research. Do your own research. Read the newspaper, see what people are talking about in politics, figure out how government works. I don't know. Okay. And then when you do a master's, you deepen the specialty. So for example, I have a master's in education. So my graph will look something like this. And then you will do when you do a PhD, you are reaching to the end of the circle of all there is to know in the human knowledge. But there are many things I don't know. I don't know how, I don't know, I'm not an engineer. I know what engineer people do, but I don't know how to do their job. I know what accounting is, but I can't do anything beyond basic accounting. I can read Mandarin, but I definitely cannot analyze a very, very old piece of Chinese text. But I can do education because this is my specialty. So you think that, wow, I got PhD, I can change the world. No, we need to zoom in to the little corner that you make. This is your PhD. But if many people do different PhD in different areas, it will make it bigger. But it is years and years of practice. And it's also a commitment to the knowledge, which it's fine. Here is okay, can now, go liao. Some people, it's not meant to study one. But if you're like, I really like maths or the algebra thing, I super like, I see liao, I very happy. Yes, this is you lah, then continue lah. If not, then you just want to learn a little bit more so you can work better in this world. Can. Teacher, how do I know which one I am? You wouldn't know, or maybe you already do. It's a journey. So like playing any game. We start first lah. Let's go, then see how. Adjust and see how. Okay. So there are 2 more questions in this paper. All right. So it's 40 marks, meaning I just set half a paper, not the whole paper. Okay. So here we have an object moving down in a straight line at constant speed. A force is applied to the object. Okay, so if it helps you, I guess we could draw. So I have an object that is moving in a straight line at constant speed. So maybe this speed is 10 meters per second. Okay, and then we apply a force. Okay. I give you a few options. I can apply a force in this way. Scenario 1. You tell me what's going to happen. I can apply a force. Again, the object is moving here, 10 meters per second. Now I draw smoke trail for you. The object is moving. Okay. I can reverse the force. I flip the force on. This F. Scenario number 2. Tell me in the chat, what do you think happens to object number 1? Changes in its motion. So when we say changes in the motion, it means changes, you think a bit, changes in the speed. So for physics, change very easy one. No color change, not like chemistry, you have to memorize color change, right? So only got increase, decrease, or no change. So scenario 1, increase, decrease, or no change, choose one. Scenario 2. And later I'll give you a scenario 3. Okay, let's see. 1, accelerate. 2, decelerate. Can. Accelerate. Decelerate. If you don't want to use these terms, physics allows you to say the speed is increasing. Why is it increasing? Because the ball is rolling to the right and then you pull it to the right. So of course the ball is going to move faster. Or maybe you give it a kick. Let's say you're running behind a football and then you kick it from the back. Boom, it will travel faster in this direction. Let's say the football is rolling towards you and you kick it away from you. So then the speed is decreasing. Or you could even say the ball may be stopped. Don't know, depends. Need to calculate this one. All right. Third possibility. Can you think of a third possibility? I draw for you. So still same scenario, still football rolling on the field, and then you kick it in this direction. Wow, like David Beckham, bend it like Beckham. What happened to this ball? Would there be any change? Go southeast. Southeast. Okay. Wait. Let me move the meeting control bar elsewhere. Okay, go southeast. Very interesting suggestion. Let me label where is south and where is east here. South is here. East is here. In this direction. Right diagonal. Meaning it goes here. Are you saying it goes here? Okay, interesting observation. Okay, let me ask you a different question. This one is a little bit out of syllabus. I'm not sure. But let's say you have an object like that. Okay, and then this ball is rolling off the table. Okay, in fact, I think I have a recording of this. Ball is rolling off the table. When the ball rolls off the table, how would it fall? What do you think? How do you think this ball is going to fall? Because, right, let's say the ball is rolling off a table with a speed of 10 meters per second. We got this force called what? Say it loudly. I mean, don't say it loudly because you're at home and probably you scare your parents, but say it loudly in your brain. Gravity, teacher. Gravity, pull it down, correct? Gravity. mg, weight. You got roll things down the table before or not? You roll down and see. Roll something that won't break. Don't roll your glass. Don't roll your bay. How does this one fall? Does it fall in a straight line like this? How would you sketch the path? You can click annotate and draw here for me. How would the ball travel? Well, I go and find my. recording of me doing this. Oh, Jordan, straight, just flat like that. Just like that. Oh. Interesting. Okay. Raise your hand if you think it's going to be a straight line. No, raise your hand if you think Jordan is right. I think, that makes sense. Okay, Maybelline, yes. Yihua also. Raise hand. 还有谁? You think Jordan is right? This one. You think this one is right? Go this way. Okay, great. The rest, didn't raise your hand. Do you have any other information? Or you just don't know? Okay, raise your hand if you don't know. Don't know. Matthew don't know. Okay, never mind. Okay, great. I will, hang on, let me clear this. Thank you, Jordan, for drawing. Clear, how to clear? Okay, now I feel like a boomer. There we go. 很少用嘛, this one. Okay, so you don't need to. It's me lah, same person. Okay, so it's fine. So in this video, right, we're gonna look at a bunch of projectiles. Okay, so I thought, but I want you to look at the machine. So you see all of these are projectile. Do you see this thing change direction? It goes up and then it come down. What caused it to suddenly go up then come down? Who made it happen? Go up, come down. You launch. By the way, this is Law of the Rings. Never see before. Go watch. It's still the best show ever. Boom. Okay, so question. What causes it to change direction? I like this one. See this dude. My dude is like, I know physics, I calculate. I know when to step away. Okay, so when you look at something, right, like a projectile motion, okay, this is my colleague and me. So you can see it follows that trajectory. So what Jordan was drawing is the top part going down. Okay, and of course, there are a lot of other things there that we don't really talk about, but the whole point here is it follows a up then down motion. Okay, and you will level up drawing this graph later in A levels. But right now, this one means that it will change direction. This one is a very strange change. It's like it's moving horizontally and then go down. Very weird, right? Because change in direction based on our experience is just in like that. So we expect this kind of change in direction. So it's a bending curve, but you don't have to write that much yet. We're going to say that it changes direction, but keep in mind that this will be chapter 2 in your A levels. Okay, changes direction of motion. Yeah, it's going to go down like this in the curve. Why is this out? Hello, excuse. Okay. So this question now is going to, you write any of these two, you get 1 mark each. Okay, if you're marking your paper, just give yourself 1 mark for any of these. Speed is increasing or speed is decreasing. So anything along the same row you got right, then you get 1 mark. Okay. All right, so here a skier is taking part in a speed competition. Okay, so by the way, this change in direction, right, is just because the weight is pulling it down, but it still want to move forward. You know, to help people who have trouble visualizing, because too long 没有打篮球的. The ball still wants to go here, but the weight is pulling it down. The ball still wants to go here, but the weight is pulling it down. So it will gradually go back down. Okay. Go through some stuff. Anyway, here's a skier taking part in a speed competition. The winner of the competition has the highest average speed. Oh, highest average speed over 100 meters. So I don't care what happened before this 100 meter. I only measure your speed here. Like Olympic, you got watch the Olympic track. You watch Olympics. What to do at home now, lockdown, you watch Olympics. So I don't care how much you run before, but I just care about this 100 meter. So the skiers start from rest. Okay, all this important information when you read this kind of kinematics, must start from rest, has constant acceleration, and reaches a speed of 60 meters per second in 16 seconds. Calculate the skier's acceleration. So whenever you think of acceleration, you should think, and the symbol is A, you should think about change in speed. Changes in speed that is happening. Okay, so it depends on whether the speed is increasing or decreasing. But in this case, it starts from rest, so V is equal to 0. So speed, I'm going to use the symbol V. Okay, so you're going to start from 0, and then it will reach 60 meters per second in 16 seconds. So your V now is 60 meter per second. So acceleration A is change in velocity divided by change in time, or the time taken. So this will be 60 minus 0 divided by 60. So 60 divided by 16 is 3.75 meter per second square. Okay, so make sure you write your units. 3.8 also can, but 3.75 is preferred lah. Some of you may be thinking, teacher, the graph, can I use graph method? Well, if you are, well, that's really great of you thinking about that. So your graph will look like that. This is meter per second. So graphing is an important physics skill. Sometimes you should just draw the graph just to like, okay, Lord, it looks like that, Lord, like some doodling. When we start here, t equal to 0, the velocity is 0. We start here. After 16 seconds, the velocity here is 60. And it says that it has constant acceleration. So constant acceleration means your VT graph, A, your VT graph, gradient is equal to A. And if A is constant, this one is also constant. Okay. So you're going to get a straight line like that. So how do you find the gradient of this triangle or this straight line there? 60 minus 0 over 16. The gradient. Teacher, I half can, but don't. Why would you do that? This will be 30. Teacher, I have some more, sure. 4. This is 15. So this is what we mean by constant acceleration. At every equal time interval, we will increase the same amount. 4 seconds, increase 15. Another 4 seconds, increase another 15. Okay? And then increase like that. So 3.75. So this means in 1 second, the speed increase by 3.75 meter per second. This is what the 3.75 meter per second square means. And this is why when we see acceleration, we see change in speed. And also why I say accelerate, speed is increasing. Okay, 2 marks. You show this working, you get 1 mark. Final answer, 1 mark. All right, next part. Part 2. Over the length of that 100-meter section, the time recorded is 1.65. Calculate the skier's average speed over the section. Okay, so if I want to find average speed, I will take distance traveled over time. Distance over time taken. Okay, so always understand that there are 3 things that we're talking about. We're talking about distance, which is how far, and then speed, which is distance over time, But this will only work if you look at the change in, I put delta to show change. Triangle, I write here, triangle here means change. Later you learn more maths, you will see the triangle appearing. Okay? Change in distance over time. Just like acceleration can be change in speed or change in velocity over time. Okay, so it's all level up one. Level up from this, level up to this. Okay, so now you take the distance over time taken. This is 100 over 1.85. So if you take 100, you write the working 100 over 1.85, you get 1 mark. Then this is 54.1. Generally, you write 3 significant figure is enough, but make sure it has a unit, meter divided by second. Meter divided by second. So this one mark, then you show the substitution is 1 mark. You write equation, don't write equation, CIE will not penalize you, but if you write, it will help you double check. Okay. Suggest why the skier bends his body though. Why he crouched like that? What happened? What you think? Why he don't stand up like that? I'm the king of the world and then ski down the 100 meter. Gravity? Is that why? I mean, gravity is causing him to accelerate. You are right. Why doesn't he open up like everything just like I reduce air resistance? Correct lah. You got see Malaysia the silver medal or not? You see the Malaysia silver medal race? No need to see the silver. Let me see if I can find. There is something. You only watch badminton. Yeah. Right, head is playing. But what else? Air pressure. Air pressure causes air resistance, but that's not really why we crouch down, especially when we're traveling on high speed. Okay, so if you look at this one, the Malaysia one and only silver medal in this Olympic, we only got 2. No, don't have I, never mind. So you can see they're all crouched down one. See? There are 2 reasons. One is air resistance. But what's the second reason that we write this way? Hang on. You look at the writing. He has a vlog. Okay, I can go and stop him later. But is there a part where there are people? Okay. You look at the part, right? Why do you think they need to crouch down? Well, on one hand, they are going very fast. But what happens when you go very fast on a very thin wheel? Because I don't know about you, but the wheels of the bike looks quite thin.
What makes me more nervous is that it's the racetrack is tilted.
Correct lah. Good observation. The real track is tilted. You look at the wheel. It's like a 2D wheel. There's like cardboard wheel. Is it stable? I need to find one where he is racing and not. Okay, good enough. So you look at these people. They're cycling. Look at how thin the wheel is. Why do they crouch down? Number one, you want to decrease air resistance. You look at the helmet. The shape of the helmet is slightly curved one, aerodynamic helmet. Have you ever been on an unstable platform before? What is your tendency when your platform is not stable? You crouch down. Look at him, man, 70 kilometers per hour. This is his coach. His coach. This is his coach family. This is his family. Okay, anyway, why doesn't he do this? Air resistance. Streamline shape like a fish. It's not very shaped like a fish, but if you look at here, the back part of the helmet is thicker one. Takkan his head is like that, right? His head is probably here. There's extra shape there. So the wind, it decreases air resistance. Why does he wear this clothing? Skin tight and also smooth, so that decrease air resistance. But why does he need to crouch? So that he is more, show of abs. No lah, so that he is more stable. Because you lower the center of gravity, right? If you sit up straight, your center of gravity is higher. You crouch, where can see your abs? The center of gravity is lower. Okay, so you bring down your center of gravity, so it's more stable. Like when you are sitting down, you are more stable, harder to push over compared to when you are standing up. And then if you have certain friends who are very tall one, their center of gravity is higher, they're easy to push over. Then you better start running because their legs are also longer. Okay, so the skier here is crouching in a similar way as our Keirin silver medalist because number one, decrease air resistance. Decrease air resistance. I'm going to have to explain your answer. Okay, so you can say when he is when his body is bent, I follow the sentence lah. When his body is bent, the area in contact with air is smaller. He is more aerodynamic. So in a long round, aerodynamic is air pressure. So there is something about air pressure here. We're going to have to relate this with being more aero. So if you say decrease air resistance, you only need one. So if you write this one, you get 1 mark. And then the second mark is when you say, oh, he's more aerodynamic. Or you could say the area in contact with air is smaller. He crouches down. Or this one, area in contact with air is small. Now the aerodynamic helmet, the very 夸张 one, look at this one. This. Look at this. Haha. Okay, I'm going to screenshot and draw some airflow on top of this person. So aerodynamic is like, you know, you cycle very fast and then the air coming. Phew, then the air will go like that. The air will flow this way. Okay, so aerodynamic. If you are not in the aerodynamic position and then you just sit up and ride a bicycle as normal, because that one will, oh, there's a beautiful one here now like this. So if you use a normal helmet like this, you will notice that this part will have a lot of collision with the air particles. Google is my best friend. So yes, all the wind hits here go up. That's why then his face is tilted downwards one. Actually, I also don't know. Maybe he just looked like 1 meter in front of his wheels. Still dangerous. I agree. Okay, this one. You can see the airflow here. Wow, the airflow 来了. So this airflow will cause a lot of air resistance. I mean, not a lot. It's still okay because he got this little tiny flap here. So the airflow can go like this. If you want a nice one, then it should be a totally curved front and back portion. Okay. Yeah. All right. Anyway, that is the aerodynamic part that most of you will recognize. And another answer that I accept, if any of you writes this, is that this is to lower the center of gravity. So that the skier is more stable. So you say lower center of gravity, 1 mark. Why you want a lower center of gravity? So that the skier is more stable, 1 mark. Less likely to topple over. And doesn't fall. Yeah, and you pointed out correct. K-rins, right? The track is a tilted track. I show you lah, because also learned that in college one. I got take a good screenshot of that K-rin race. Okay, copy all them. I move on now. I'll put this inside your Google Classroom. Nah, the track like that one, you sang it. Danger. It's okay, it's okay. They are trained. Okay, all right, move on. Question 5. State why force is a vector quantity, because force has both magnitude and direction. Must write this both magnitude and direction. Okay. A 20 Newton force and a 15 Newton force acts at the same time on an object of mass 14 kg. Calculate the maximum possible force on the object. Okay, let me draw the object for you. We have the object. I'm just going to draw a box because what else do we push and pull on? Just box. So let's say 20 Newton is here. So your 15 Newton got a lot of option 1. Let me show this to you in a handy dandy simulation. I have so many tabs whenever I teach IG. I'll send you the link. Hang on. All right. This is the vector. Okay. So we have 20 Newton, right? Can I have 20? Yes, I can. Okay, so 20. Like this. 20, yeah, up here. Okay, what's the other number? Like, one is 20, the other one is 15. Okay, I'm going to put another vector there, and it's going to be 15. Vector B, okay, 15. So I make sure I keep the length 15, like this, and then I can draw the sum of the vector. So vector S for sum is A plus B. So this one is where you get maximum. You got 20 and 15 pointing in the same direction. Doesn't matter whether it's left, right. You want up, down also can. Left, right, up, down doesn't matter. Okay. So as long as they're in the same direction. So let's say I change it to up, down. I don't think up, down got space now, but another way to understand this is, let's say I don't touch B, I just touch A. Let's say I change the angle of A. I try to keep it at 20, but I change the angle. Okay, maybe I change the angle to 90 degrees, but I still want 20, right? Okay, so 20. Nah, 90 degrees. You can see this vector is less already because of Pythagoras theorem. This one go down. You take A plus B, you get S. Okay. A is 20. So just now, it was 25. Now it's already 20. If I want to make it smaller, can. I just keep changing the angle. Because when I keep changing the angle, while trying to maintain this one at 20. You can see this one is getting smaller and smaller. Now it's 19. So the maximum possible one is when they are both parallel. Teacher, the minimum one, minimum one even easier. Parallel but opposite direction. So let's say I change this one to 20, but in the opposite direction, like this. And then I add with B, but B is in the opposite direction. Then my S is here. This plus this is this. So if you want maximum possible, you will take 20 plus 15. 35 Newton. Condition. The 20 Newton and 15 Newton parallel and same direction. Okay. Teacher, minimum leh? Okay. Minimum force is 20 minus 15, which is 5 Newton. So the condition for this one is parallel but opposite direction. Okay. This one going to be like this, like this. This one is going to be like this. All right. Okay. Acceleration caused by force equal to this maximum force. So whenever you see a relation or a question trying to link force and acceleration, we will think of Newton's second law. Newton's second law say what are F equal ma. So we have the mass. Our mass is 14 kg. We are looking for acceleration A, and the force is 35. Okay, mass is 14 kg. So from here, we can get our A, 35 divided by 14. This will be 2.5 meter per second square. Okay. Teacher, can I write Newton per kg? Because I took Newton, 35 Newton, divided by 14 kg. Can. Newton per kg. Not a common unit, but can, acceptable. Okay, moving on. Got some more? Oh, God. Okay. So now new question now. We found the maximum acceleration. And from here, my friends, my dudes, we can ask you to calculate speed, velocity, distance. This question can be continued if needed. Just pointing it out. All right, final part of the question. This one is a river with the velocity of the flowing water is this much. Okay, I see the water. The water is going here. Okay, great, great. The swimmer sets off from one bank. Okay, I'm going to paint my swimmer green color. So the swimmer is going to start from here, I guess. The velocity of swimmer relative to the water is 1.2 meter per second at 45-degree angle to the riverbank. Oh, they draw that like this. In the space below, draw a scale diagram to determine the resultant velocity of the swimmer relative to the riverbank. This velocity is the resultant of the two velocities. Label this resultant on your diagram. 3 marks. Wow, many space. We need to draw a picture. Okay, so if you haven't drawn yet, I will draw with you. But I'm gonna use a different camera. Okay, just bear with me as I set up this high-tech OHP camera. Okay, just give me a sec. I need to get some paper. And also, oops, protractor, ruler, and adjust camera. Wait, let's see. Oh, you see a very blur vision of, okay, hang on. Need to turn off filter. None. None. Okay, there you go. Okay, this is my table. Unfortunately, it is rotated, which means you will take the seat of my coffee cup. Well, you ready or not? We go draw together. Yeah, need to do some desk logistic so that this one can fit here. Okay, can see? Is it too bright? Okay, maybe this is better. Okay, hang on, I'll stop share screen. And I will spotlight myself. Start, spotlight, spotlight. Clear mode. Okay, what is it that we want to draw again? We got two velocity. One is the swimmer, and the other one is the, what do you call it? The water, right? So generally speaking, right, when you want to start to draw a vector diagram, you have normally two vectors that you want to add together. Okay, so maybe I sketch out first. 我要看我做个 sketch 先嘛。You study, Sunny, the teacher always tell you, you sketch first, then only draw the right thing. Okay, I sketch first. So this is my bank, in case you, walao, cannot see. Excuse. I use pen, so this one cannot rub. This is my river bank. Okay, let me bring down a bit so you can see. Can you see? Okay, it's my river bank. And then, holy cow, focus. We have the water in this direction, 0.85 meter per second. And then we have this swimmer in this direction, 1.2 meter per second. I want to draw the resultant, meaning I want to fit these two arrows together so that they form a triangle. Okay. I copy one by one. I start with 0.8. Okay. First, I got 0.8. This is just a sketch. It's not the actual diagram. 0.85. After I draw this horizontal arrow, I continue. So yeah, just a bit so you can see clearer. I continue to follow this 1.2. So it's going to be 1.2 in this direction. Of course, it has an angle. So this angle here is 45 degrees, correct? Okay, so if this angle is 45 degrees, meaning this one should be 45 degrees because this water is flowing horizontal to the river bank. Okay, so time to think a bit. If let's say I start from here, let's say I call this point A, and then I reach point B, and then I travel to C, is it the same as me taking the shortcut? Let's shortcut our way like that. This. It looks the same color. I am disappointed in my purple pen, so I shall draw red. So it looks like this. This is your resultant, the red one. So we are going to build this drawing, but with a ruler and a protractor. If you want to be special and use a compass, I'm not going to say no to that, but I will leave that to you. So I'm going to draw that. But before we start, step one, we're going to have to decide a scale. Decide a scale. So normally, right, in the exam, you will be allocated about half a A4 paper size. So that should be around how much space you should give yourself, around half a A4 paper. So if I look at this 0.85, I have a few options. So it's my very old ruler. I don't know why change color lah, okay. If you take 0.85 cm, 好像很小嘞. You draw the triangle so small only, so sad. So how about we draw 8.5 cm? Can fit, right? You draw 8.5 cm in your paper. So I'm going to use 0.85 meter per second is equal to 8.5 cm. So this is what they mean by a scale drawing. I will draw a horizontal line 8.5 cm to represent this vector. Okay, and then after that, I'm going to draw 1.2 meter per second. This will be equivalent to 12.0 cm. Okay, so these are the two things that I will draw. But on my diagram, I must remember to number 2, label the scale. Label and state what scale you will be using. So the way you can state the scale is 1 cm is equivalent to, okay, see, 12 cm is 1.2. So 1 cm is 0.1 meter per second. So what is left in step 3 is just to draw. Draw. But you use ruler, you don't just, I think this much is 8.5 cm and give me a heart attack, okay? Focus. All right. So I'm going to draw now. Maybe you want to draw together with me. That'll be great. Take out a piece of paper, flip to the back of your exam paper, and just draw. Because during an exam, you're giving a blank page. I could draw on graph paper, which is the SPM method. But during IG, they don't give. Okay. Which color easier to see? Red and blue, right? Okay, I'm going to stick to that. And I pray I don't draw wrongly. Because this is pen. Okay, anyway. 紧张 time. Okay, a few notes. Okay, let me zoom out a bit. You look at the size of my paper. I have A4 paper. So I got a lot of space. See? You always need to budget space one, right? You look at your sketch here. This sketch, eventually, 你要画12 cm. You want to draw 12 cm. If I go and draw my 8.5 cm right up here, I got space to draw. Space, no? No, always set all like that. So you always sketch a small, you can erase later lah. Okay, don't need to show teacher also, never mind. Okay, so always make sure you got space. You think to yourself, okay, I draw 8.5 here, and then I put my ruler. Okay lah, can fit, right? Okay, then can. All right. So sometimes then you draw again, no? You cannot see, then you draw again. Okay, I'm going to draw 8.5 now. Teacher, I need to make sure it's parallel to the side of the paper. No need. I mean, don't draw it too weird, but because we use this beautiful thing called a protractor, it doesn't matter. So I'm going to draw to 8.5 here. Go down. Okay. So to help us brain, remember the model that we sketched just now? You don't have to label this, but I will label this just to help us know our orientation. This is A and B. So I'm essentially just copying this part of the line. Okay. And then I will draw an arrow here. This is 0.85 meter per second. If you want to label everything properly, then you say this is velocity of water. Don't label also, never mind. Understand now. Okay, now we have to draw this 45 degree. Protractor. You know how to use or not? Okay, your protractor and my protractor may not be the same protractor. This protractor I took from the lab one, okay? So I want to measure 45 degree, but this is the center of my circle. Yeah. 45 degree here. Okay. So I need to make sure this one is smack on top of B. Okay, because I'm measuring the angle from this line. If I put this one here, then it's very weird. That means I'm drawing 45 degree from here. So if let's say I'm looking at 45, let me zoom in a bit for you to see. Whenever I zoom in, I have to move the camera, so it's going to shake a bit. Sorry if it causes you some motion sickness, but okay. So if let's say I put it in some middle point here, 45 is here, right? The angle between the line that I draw and the pencil is 45. You don't want 45 here, ma. Where do we want the 45 to be? We want the 45 to be here. we are not drawing a line here that is 45 degrees. This is not what we're drawing. We are drawing it 45 degrees at B. So this center of your compass, protractor, protractor. Sorry, I learned this time, the time I learned this thing, it was in BM. This is called penyukat sudu. Sudu? No. Penyukat, I don't remember. Penyukat something lah. Okay. So you're going to put this one B here, the protractor we put here. Okay. I'm going to angle it out to 45, so it's here. So you read law. You can see, right? From the line, teacher got two leh. I read 170 or I read 10. You use logic or? You think from here to here. Okay lah, sorry, I use pencil this one, although my pencil very dull. You think from here to here, if I draw a line, pencil between this must be 10 degrees, right? So we will read the bottom scale. But you can use logic, right? If we measure angle from this side, then it will be the top scale. Okay, so we go 10, 20, 30, 40, 45. So for physics, definitely please use your protractor. Unless you just want to have a weird flex of using your compass and build the perpendicular bisector, then sure, no one is going to stop you. 45, okay, then move it away. So I know any line that I draw joining point B and the mark that I made just now will be 45 degrees from this horizontal line. And now I need to draw 1.2 or 12 cm. Okay, of course, I am obliged to tell you that if you use the compass, it is more accurate lah. But you know lah, never mind lah, it's okay. So I'm going to draw 12 cm now. Hopefully you have a protractor is able to do this. All right. 12 cm. Oh, you didn't see. Okay, so 0 here. Sini kosong and then see 12 cm. Okay, so A, B, and this one's this must see. You don't have to label A, B, C. I'm labeling this to show you what I'm modeling here. Okay, and I better put in the angle. This is 45 degrees. Okay, and here is 1.2 meter per second. And if you want to, you can say, I don't want to copy the whole thing lah, velocity of swimmer go liao. The label is not as important as the number, the magnitude. Okay, so from A go to B, go to C, A to B, A to B to C is the same as A directly go to C. Okay, lor. Of course, during exam, you draw pencil, right? So you are not using different color, meaning normally for resultant, we will draw two-headed arrow like this. And they say here, label this resultant on your diagram. So I will say that this two-headed arrow, this is right beside the arrow, I will write resultant velocity. Okay. So to find resultant velocity, we use back the ruler. We measure the length of A to C. I don't know what is yours, but mine looks like 8.5. 8.6. What's yours? If you draw with me, let me know in the chat. The angle of the line doesn't matter. It's the length that matters. So it looks like 8.6 to me. 8.6. Oh, you got 8.6. Okay, I also got 8.6. Okay, so let's say the resultant velocity is 8.6. So from the diagram, just write a statement here. The resultant velocity is equivalent to 8.6 cm. But you see, the scale that we use is 1 cm is to 0.1 meter per second. So this one will be equal to 8.6 cm times 0.1. Because this is meter per second for every cm. So the cm and cm can cancel and you will get 0.86 meter per second. Teacher, I didn't get 0.86, I got 0.85, I got 0.84, I got 0.87. Can. Normally, they will allow a range. Okay, so I think the acceptable range is, wait, I got formula one. I can actually calculate. So let me calculate what the exact thing should be. Well, I leave this here for you if you need to copy anything. 0.85 squared minus 2 a b plus 5. Okay, so the correct mathematical answer is this. Close enough. So I will accept anywhere between 0.84 all the way to 0.86. Or in other words, if you get anything between 8.4 to 8.6 cm, you are okay. So normally it's plus minus 1 mm. They will allow that. Your pencil too thick, your pencil too thin, you didn't draw it exactly a line, something happened, but it's close enough. Okay, so just make sure on your drawing, when it's 3 marks, right? 1 mark is when I check the flow. A plus B plus C is equal to A plus C. So 1 mark here is for the diagram. Diagram and arrow. Okay. The other mark is for scale and label. So I will write out the scale. I will just write big here. Scale is 1 cm is to 0.1 meter per second. Scale and label everything, especially resultant velocity. Okay. Final mark is when your resultant velocity, resultant VR, is between 0.84 to 0.86 meter per second. So for accuracy, did you draw a proper diagram? And then you also should show the length multiplied by the scale. So 8.6 cm times 0.1. So we convert the physical quantity to a drawing. And this works for vector. Scale is quite important. That's why they test you. Okay. Ken, how's life? I'm going to leave it here for a while in case you need to stare at it for a bit. Maybe I should lift it up, but it feels like it's big. It should be bigger. Okay. That's it. That's it. Actually, got a big fan blowing in my direction. That's why. But yeah, this is the final part of the paper. Okay. Any questions? Questions? Confusion? So I'm taking the time to go through this with you because most of your, in fact, all of your test papers are inspired by past year questions. Okay. Which is why it's important to know how they ask the questions and know what is required of you. Right? Okay, I'm going to leave this on for 1 more minute and then I'll continue to the next thing. 30 seconds, 1 minute until I drink my coffee. Okay, if you are done, I'm going to switch up the screen. I'll give you 2 questions to practice. Okay, this one. Just drawing the diagram, make sure all the labels are in place, and also measuring this thing. Okay, I got a question. Curiosity. You let me know. I do survey. Although my survey only got 7 people, but also survey lah, kan? Do you prefer if teacher draw like that or draw on the screen? What do you prefer? Bear in mind that after like this. Why? Because you want to see my hand. Why? Curiously, why is this better? 摇来摇去 and then out of focus, in focus. Is it better? Okay. I don't know. I mean, this one, I understand why, because I need to show you how to use these tools. So it only makes sense if I show it like this. So certain times, if needed, I'll bring in this camera, but it's also a bit weird. Okay, but yeah, or you think about it, why do I prefer this? Okay, let me know. Is it clearer? Is it more old school? And also, this means that you know, you won't see it in your notes now, so you better make sure you copy. I mean, I can take a photo for you but okay, let me adjust back the video to my face. Confirm my background bit and change the camera. Okay, there we go. I'm back. Okay, thank you. Okay. I use this to record experiments. So whenever I want to use like instruments, and then my student at home cannot do lab, you look at me do. 看我做. Okay, 来. All right. So I'm going to upload this one. I will put in this one for you. Okay, I put inside. So I'm going to upload it. You need it as reference, but hopefully you understand because I took the time to do it with you. So no keyboard, put and zoom in. Okay, zoom in, zoom out. So homework. I'm gonna give you 2 questions to do. Just 2, not that many. Some a bit similar to what we have done. So I will roughly talk you through it, but you try and submit, okay? So I can take a look at your picture. Okay. So now, see a boat, you see a water, same thing, the arrow direction, be careful, this one is going this direction. They're just rotating the picture. Water, swimmer. Boat, water. Same thing, okay? So again, show the direction of resultant velocity and then determine the magnitude. Use the scale vector. Okay, and then you underline all the scalar quantity. So I want the diagram, but do see also lah, as an exercise. Okay, and the second one we shall do will look a little bit different. It's because we need to level up ma. I'm going to have to label the questions. Hang on. Because part A is missing, part B is missing because I didn't give you everything lah. Okay. All right, this is question 2. I will label them for you. I'm just going to leave in this. Okay, this one is a bit different. No diagram to copy, meaning you have to sketch it yourself. Okay, and this one you need to infer some information, which I will start just to make sure your drawing is not a bit weird. Because the previous one, we looked at velocity, right? Now we look at the path taken by the girl. Oh, she walked how far? Okay, so she run due north, 120 meter. Where is not? Oh, up 120 meter like that. Due north is just the Angmo way of saying towards north. Okay, so she runs 120 cm due north. And then she runs 80 meter due east. You know what to do, hopefully. Okay, draw and label her resultant displacement. Okay lah, 自己来啦, okay. I will erase this when I print. Okay, then you find the magnitude and the angle. Use the drawing. You know how to measure angle? Use this one also. Okay. If you don't have how, print one. I don't know. Draw one. Shopee one. You don't have how, you do maths or. Okay lah. I think that's it. If I decide to add another one, it's just for practice. Okay, but I think you're good. All right, I'll see you next week. We will continue our journey in pressure. All right, so the last place we stopped was, if you remember, we stopped at fluid pressure. Remember this damn one, this HOG. So after that, we're going to look at how we use this fluid pressure to brake, to do hydraulic braking, or to lift up heavy things. That'll be next. Okay, it's quite popular question as well. And then we will end with gas pressure. All right, wait, don't go first. I'm going to